In this chapter, we're exploring a different coordinate system. We're looking at graphing points and equations in the polar coordinate system. And when you see the polar coordinate grid, it's going to look very much like a unit circle with a lot of concentric circles in it. The origin is the pole, and the polar axis corresponds to the initial side of the angle in the unit circle. So in example 1, when we're asked to graph each point, on this example I don't have a polar grid, so what we're basically starting off with is, here's, you could consider my positive x-axis in the rectangular system. This is the polar axis in the polar coordinate system. So every time I graph a point, I need that polar axis there for reference. So I'm going to need one for each of these. So for part A, my point that I'm graphing is -1, pi over 2. That means that my point will be 1 unit away from the pole and forming a pi over 2 angle with the polar axis. So pi over 2 on your unit circle, you know, is this angle. But if it's -1, then I need to be going in a negative direction. So I would indicate that this angle is pi over 2. I would indicate that this length is 1, so that this point would be read as -1, pi over 2. In part B, my angle is 240 degrees. Remember, that's going to be 60 degrees more than 180. So that would be about here, again indicating that this is 240 degrees. And in order for this point to represent 2.5, 240 degrees, I would need to indicate that this length is 2.5. Finally, for part C, it's 4 units long, and the angle measure is -5 pi over 6. Well, if you're looking at your unit circle, this would approximately be +5 pi over 6. But if I'm going in the opposite direction, if I'm going in the negative direction, then what I'm looking at is this angle, and if this point is to be 4, -5 pi over 6, I would indicate that this length is 4. So this is a little bit easier when we have the actual polar grid to plot points on. So let's do that. I have 1.5, -7 pi over 6. So if each circle is representing 1, then this is 1, 2, 3, so on and so forth. -7 pi over 6. Each angle marking is 1/6 pi. So that means this angle here would be 7/6 pi, -7/6 pi. So my point would be here. This point would be 1.5, -7 pi over 6. Part B, negative angle and negative distance. So let's deal with the negative angle first. I know that from here to here would be 90. To here would be 105, 120. Here's negative 135. And since I'm going negative 2, I'm not going towards that negative 135. I'm going away from the negative 135. So I'm on the same line, but going in the opposite direction. So I would be here. This point is negative 2, comma, negative 135 degrees. And so you may already be realizing that coterminal stuff from back in chapter 4 is coming back to haunt us. There's more than one way to represent a point in the polar grid. So if I have the point 5, 240, what are 3 other ways that I can name that point? Well, let's plot that point first and then kind of go from there. So 5, 240. Here's 180, 195, 210, 225. Here's 240. And I want 5, 240, so 1, 2, 3, 4, 5. That's here. So I think about what 240 is coterminal with. 240 is coterminal with negative 120. So I could rewrite this as 5, negative 120. Or if I consider this line, that would be, if I'm looking at negative 5, I could do negative 5, comma, 15, 30, 45, 60. Well, that 60 is also coterminal with negative 300, so this would also be written as negative 5, comma, negative 300 degrees. So that's 3 different ways that we can express the same point. For part B, again, I'm going to plot the point first. Here is the angle pi over 6. So 2, pi over 6 is here. Let's think about what pi over 6 is coterminal with. If I take pi over 6 minus 2 pi, well, in order to do that, I would need a common denominator. So I'm going to rewrite that 2 pi as 12 pi over 6 and get negative 11 pi over 6. So that means I can rewrite this point as 2, negative 11 pi over 6. And then I could also think of that 2 value as being negative. So remember the strategy from earlier. I'm going to extend this line. And what it's equivalent to is 7 pi over 6. So I could think of this as negative 2, 7 pi over 6. And I can do the same thing with this 7 pi over 6 that I did with the pi over 6. I can find what 7 pi over 6 is coterminal with. So 7 pi over 6 minus 12 pi over 6 is negative 5 pi over 6. So I can rewrite this as negative 2 comma negative 5 pi over 6. And since there are polar coordinates, naturally there are polar equations. And so we're just looking at the simplest kind right now, r equals a number or theta equals a number. So if r equals 3, then what I'm looking for are all of the points on this grid that are 3 spaces away from the pole. Well, here's the pole. Every point that is 3 spaces away from it is on this circle. For part B, I'm looking for every point that is forming a 2 pi over 3 angle with the polar axis. So I know that this is 2 pi over 3 on my unit circle. So what this boils down to is this line. And those are our 2 simplest kinds of graphs, a circle or a line. In Algebra 2, hopefully, you saw this formula, law of cosines, that can be used to find the missing side of a triangle when you know 2 sides of the triangle and the included angle, and it's not a right triangle. So if you just look at this part of it, that should look really, really familiar. It's Pythagorean's theorem. Okay, and then we're subtracting away 2ab cosine c. The formula for the distance between 2 points on the polar grid is derived very closely from that. And so you see the distance formula for polar points given to you on the screen. So let's use it. In example 5, I have 2 points, one at 8, 150. So 8, 150. Well, where's 150? Here's 150. And 8 would be right there. And 3, 65 would be 30, 65 would be about, that's about 65 degrees. So 1, 2, 3. And what I'm looking for is the distance between these 2 points. So that distance will equal the square root of r squared into r squared, so that's 8 squared plus 3 squared, minus 2 times 8 times 3 times the cosine of the difference between the 2 angles. So my 2 angles are 150 and 65. So 150 minus 65. The rest is straight calculator. So myself personally, I would want to simplify this squared stuff first. 64 plus 9 minus 2 times 8 times 3 is 48 times the cosine of, what is that, 85. So 64 plus 9 minus 48 times the cosine of 85 is 68.8 approximately. And when I hit the square root button, I get approximately 8.3.